Hello all, welcome back to the embedded system webinar series. So we have been discussing on the PN junction diode in the last two videos. So we have talked about the forward characteristics and the reverse characteristics, and then the surge current that is allowed through the diode at a given time period. Now we will continue our discussion on the characteristics of this PN junction diode. So the next that we'll be talking about is the reverse current of the diode. So now if you go back and if you see the small diagram that we have seen here, so when you apply a voltage, okay, so you see that there is a voltage that is coming out minus the forward drop of the voltage, which is 1.1. so let us assume I am applying less than 1.1 here. The output would be 0. That means when let us assume I apply 0.5 volts, the output is 0. But what is the operation that is expected when you apply 0.5 here? Ideally, if you talk about this scenario, the output is 0. So that means there should not be any current that should flow across this diode. And if you take it in a reverse way, the reverse breakdown occurs at 50 volts for this diode as discussed previously. Now let us assume I am applying only 5 volts at the reverse side here, okay, and what happens is that the output should be 0 and ideally the current should be 0. But what happens is when a 5 volts is applied in the reverse direction, you see a small leakage current that would be flowing across this diode, which is given by the parameter called reverse current. That is why in the reverse breakdown scenario, you see the graph slowly ramping down, and then there is a sudden surge at the breakdown. So this slow ramping down is because of this reverse leakage current. So reverse leakage current is one of the scenarios that occurs in the diode. Now this is given by a parameter called IR in the diode. This should be as small as possible to eliminate any quiescent current that is there. Now when you are using this circuit in a low power conditions, and low power is your major criteria, this reverse leakage current should be as low as possible. Now again, when we discussed about the diodes in the previous specifications, we saw that some of the specifications are depending on the temperature. Similarly, for the diode, the reverse leakage current is again dependent on the temperature. So now if you see this table from the 1N4001 data sheet, at a temperature of 25 degrees centigrade, you see 5 microamps of leakage current. But as the temperature increases, the reverse leakage current increases. This is because of the thermal excitation of the ions, holes and electrons that is present within the breakdown region, which tend to move towards the other side of the junction. So a more leakage current is flown as the temperature increases. So again, to put it the other way, with temperature the reverse breakdown increases, as well as with voltage. As the voltage increases, the reverse breakdown the reverse leakage current increases, which is seen in the waveform. So this is what about the reverse current of the diode. Now if we go further, there is one more characteristic called switching time of the diode. Now let us assume that I have given a 5 volts at the input, and we have seen that there must be a 1.1 volt drop, and we should see an output of 3.9. But the scenario is like, how much time does it take for the 3.9 output to come? So this is the time taken for the output to come when after the input is applied is called the switching time of the diode. So switching time is very important diode characteristic, and this depends on the junction capacitance that is there. More the junction capacitance, more the switching time. So this junction capacitance is because of the PN junction that is existing, because P and N acts as two plates similar to a capacitor. Okay, so next time when you select diode, choose this, check this characteristic. Thank you.